Dr. Brian Wright from UC Berkeley. He's the chairman of the Department of Agricultural and Resource Economics. And Brian has done a lot of work on genetic resources, intellectual property, insurance and risk management, and the markets for storable commodities. Brian?
So our first speaker is, on my right, Meredith Fowlie, a relatively new member of our department. She was produced at an excellent graduate school, and we managed, in that graduate school, managed to hire her back recently. And she works in all matters related to topics today, except maybe political science. And I'll open the floor to Meredith.
So I've been asked to talk about the impacts of AB 32 on California's electricity sector. And this is a very complicated question, and sort of the short answer to that question will come as no surprise to anyone. And the answer is, it depends on your assumptions, and we've talked a lot about that already this morning. I'm going to try and get a little more traction on that in my 15 minutes. I don't have time to delve into the details of the models we've been talking about, and as the sessions this morning sort of helped us to understand, there's lots of moving parts, there's lots of assumptions, and as sort of what came up earlier today is I don't have access to some of the more proprietary components of these. I should be clear, I'm a consumer, not a producer of these models. But I do want to try and learn something from from the results that we've been looking at today. I think we certainly can learn something from not only where these models disagree, but also where the models agree. So what I'm going to do today is start by just giving you some stylized facts about the electricity industry, things we should have in our minds as we're trying to think about how AB 32 might impact this important sector, and then focus just on some sort of more nuanced questions. What are these results telling us about how much of the emissions reductions mandated under AB 32 will be achieved in the electricity sector? What are the results telling us about how these emissions will be achieved? How sensitive are these answers to sort of our assumptions about key policy design features? And in particular, how binding or how significant are these complementary measures we're talking about? And if there's a punchline today, it's the same punchline that was sort of punched earlier this morning, and that is that policy design really does matter. Okay, so some stylized facts, which, with apologies for those of you who, like me, spend their days thinking about the California electricity sector. This won't be news to you, but I think it's important to set out some important facts before we get into the details. So first, California's electricity sector is responsible for approximately a quarter of the state's anthropogenic greenhouse gas emissions. So it really does matter when we're talking about making aggressive reductions in greenhouse gases in the state. Second, electricity imports play a really important role. So that graph on the right is just showing you electric consumption and then breaking it down into in-state generation and in-state hydro. So you can see that imports, so a fact that I actually wasn't aware of until I was preparing for this presentation is actually California imports more electricity from other states than any other state. They import about 20%. However, those imports account for almost 50% of the carbon emissions associated with electricity consumption in the state. So imports are really important to think about, and especially when we're worried about the potential for emissions leakage, we need to keep imports in mind as we're thinking about policy steps forward. Another fact that's important to keep in mind is that the carbon intensity of California's electricity sector is already fairly low. So when you look at the CO2 emissions per kilowatt hour consumed, and that's including imports, it's a little less than a pound of CO2 per kilowatt hour. If you only focus on the electricity generated in the state, which is quite relatively clean, it's 0.66 pounds of CO2 per kilowatt hour. Compare that to the national average of 1.3. So overall, we're quite clean, and that's, of course, because we have very little coal in our fuel mix, whereas coal accounts for almost 50% of the electricity consumed nationwide. Finally, we've got low emissions intensity, and we're getting lower, and this came up earlier today, and it's, of course, important to keep in mind. Several initiatives already in place or on their way to being in place, which is going to reduce the carbon intensity of the electricity produced and consumed in the state. So the 20% renewable portfolio standard, SB 1368, these are all measures we're taking and are in motion to reduce or to improve the environmental performance, reduce the carbon intensity of electricity consumed in the state. And I'll make this point was made very clearly earlier this morning. In the models that we'll be looking at, including their resources board model, the baseline scenario is one that incorporates these measures. So we're going to be measuring outcomes under AB 32 relative to a state of the world where we're doing all these things to reduce the carbon intensity of electricity in California. And finally, no matter which model you look at, the electricity sector is expected to contribute significantly to the emissions reductions that would be mandated under AB 32. So of course, this number depends on your underlying assumptions, but sort of the basic AB 32 scenario that's been analyzed by the Air Resources Board, we find that approximately 40% of the projected emissions reductions will be achieved in the electricity sector. How these emissions reductions will be achieved really does depend on what you assume about how this policy is implemented, and that's what I'd like to spend some time talking about today. So, how will these emissions reductions be achieved? Well, environmental economists, when they think about emissions reductions, certainly at an economy-wide level, to get some traction on the question, we like to sort of divide things into scale, technique, composition, right? So thinking about emissions generated by the U.S. economy, you can either reduce the scale of the economy to reduce your emissions, you can change the composition of the industrial activity, moving industrial activity towards less carbon-intensive industry, or you can invest in newer, cleaner technology, so to reduce the emissions intensity of the composition you already have. And I think a similar sort of conceptual framework can be picked up and moved to electricity, right? So we can reduce the total amount of electricity we consume, reduce emissions that way. We can change the composition of the fuel mix we use to produce electricity, so reorder dispatch, so we're using relatively clean electricity generation more intensively, using relatively dirty electricity generation less intensively, or, and these last two are quite closely related, of course, we can invest in new technologies, invest in wind and solar and clean energy that emits zero or very low amounts of carbon dioxide emissions. So those are for sort of my, wearing my economist hat, that's how I approach this in terms of thinking about where these emissions are going to come from in this industry that's already got relatively low carbon emissions. Okay, so this is the type of question I was bringing to these simulations and modeling results as I went through the results that have been made available. And so what I wanted to do was focus on the three scenarios that we actually talked about this morning. The first is the reference scenario, which does incorporate measures such as the 20% renewable portfolio standard that are going to be in place in the baseline. The second case I wanted to look at is the full complementary measures with offsets. So that's cap and trade program with the complementary measures, including the renewable energy, or the RES, renewable energy standard, and offsets. And then case two is the full AB 32 plus complementary measures, but no offsets. And so to focus on the following, just to remind you where we're going with this, really wanted to see under these different scenarios how much of the reductions are coming from the electricity sector, how we're getting those reductions, how sensitive the answers are to assumptions about whether we allow offsets and whether we incorporate these complementary measures. And in particular, and this is getting back to Chris Canetto's presentation, which I really liked, how binding are those complementary measures, right? So when we impose that 33% of electricity generation has to come from renewables, would that have happened anyways in a regime where we allowed the market to find emissions reduction opportunities? Or are we imposing it and we wouldn't see that level of investment absent those complementary measures? And I think we can learn that from looking at these modeling outputs. Okay, so just to show you some numbers, and these are taken right out of the Air Resources Board study. The first column is just showing you baseline, what the emissions we project in 2020 if AB 32 doesn't happen. The second column is the percent reduction under AB 32 with offsets, allowing offsets, and the final column is AB 32 without offsets. And here you can see that we really are relying pretty heavily on the electricity sector for some of these reductions, asking for about 40% of the emissions reductions to come from the electricity sector. How will we achieve those? Will it be through scale reductions, that is reducing overall demand for electricity? We get less than half of the emissions from these types of scale reductions under both case one and case two without offsets. And the reason I was really interested in looking at the case without offsets, when you remove the ability to use offsets, essentially you're ratcheting, you're tightening the screws on the cap, right? You're requiring more reductions to occur in California. And I think it's interesting to note that we don't see any more reductions coming from demand reductions when we remove offsets, which is basically saying that there's no more really low-hanging fruit in terms of reducing demand. We're finding those additional reductions elsewhere in other sectors or in other areas of the electricity sector. What about composition changes? You see quite a bit of action here, right? So moving from the reference case, you see in the AB 32 base case, you do see reductions in the use of gas and oil and coal, so you're seeing some redispatch. you're seeing huge increases in the amount of renewables generation we're using to meet demand. Moving from the base case to the one without offsets, you do see even more redispatch, right? You see even more reductions in gas and coal as we require more reductions to come from within California, but you don't see any more in renewables, suggesting, sort of thinking back to Chris's graph, that those complementary measures that required renewable energy investments and increased use of renewable energy, we're not going to go any farther than that, even if we require more emissions reductions to occur in California. Another way of putting that is those are binding. And finally, technology investment. Under any cases, we don't see any new investment in coal, gas, nuclear. We do see more investment in the renewables, as we'd expect, because of the 33% standard, but we don't see we don't crawl any farther up that marginal abatement cost curve when we tighten the cap and shut down offsets. Here again, suggesting that those complementary measures are binding, that they are incentivizing investments in new technologies that might not have happened in a regime that only used a cap and trade program. And don't want to use too much of my time. I'm just putting up the punchline for this is these results are generally consistent with some of the results we find coming out of the Charles Rivers and Associates, and the authors should correct me if I'm misinterpreting these results. But basically, they run a really nice scenario that says, what happens if we just rely on cap and trade and remove all these complementary measures? And they do find that you see less investment in renewable energy, less investment in energy efficiency in that regime as compared to the one that incorporates complementary measures, suggesting that those are binding. Those are delivering investments in renewables and energy efficiency that wouldn't have happened if we rely on a purely sort of market-driven regime. And so in terms of conclusions, California's electricity sector is certainly expected to play an important role in delivering emissions reductions. We're going to achieve those emissions reductions in a variety of ways: scale reductions, changes in technologies, and changes in how we dispatch plants to meet demand. These complementary measures do bind. All the model simulations I've found seem to agree that they do influence how emissions reductions are achieved. But it's how we interpret that finding is sort of an open question, right? So to extend Chris's metaphor, are the investments that are driven by complementary measures, are those fruits worth picking that we wouldn't have picked otherwise because of market failures and distortions that exist? Or are they just making the program more costly and something that we need to examine? So that's where I'm going to step back, and hopefully the discussion will address that.
Next we have John DiStasio, who's General Manager and CEO of the Sacramento Municipal Utility District. He's served previously as Assistant General Manager for Energy Delivery and Customer Service. He also serves on the Executive Board of the Sacramento Metropolitan Chamber of Commerce, the Greater Sacramento Urban League, and is past President of the Northwest Public Power Association, and is currently a member of the American Public Power Association's CEO Climate Change Task Force. So he's obviously very well qualified to talk about impacts on energy users, which he's going to do now.
Unfortunately, I was unable to see some of the modeling presentations this morning, although probably even had I seen them, I might offer a little bit of a different perspective in that when we look at it as utilities and focusing with end-use customers, we're seeing the impacts, and our utilities see it very differently depending on how they're situated. So just by way of background, I'll tell you that for SMUD, we're very fortunate. As Meredith mentioned, California, from a carbon intensity standpoint of our supply, is very good. And frankly, if you took the 47 or 48% of LADWP, Los Angeles Department of Water Power, 47% coal, if you took that out of the mix, we'd actually have a very, very clean portfolio statewide. SMUD sits as the 17th cleanest utility in the United States. Part of that's by necessity. We closed Rancho Seco in 1989, our nuclear plant, and I will say at that time our board and the folks running SMUD had good foresight, not so much focused on climate, but focused on air quality. So that resource, major resource, 900 megawatts of nuclear, was replaced with about 200 megawatts of energy efficiency, and then the balance of it was in 3 clean natural gas cogeneration plants. So that served us very well and actually got us on the path to start significant investments in efficiency and also renewables. We're at about 20% renewable. So as we sit here today and we look at the economic impacts of AB 32, first of all, I would echo what everybody else has said. Policy matters, and the details matter of how we deal with allocations, how we deal with things like a cap and trade system, whether it be an auction, whether it becomes a carbon tax, whether we have a national program. So let me just start with the fact that for SMUD, our board's already adopted effectively the goals of AB 32. We just went on record to support AB 32 and their 33% RES. As I said, we sit at 20% today. We do think there's value in the complementary measures. That said, I think it's very important that when we have a policy that says we want to reduce emissions by a certain percentage, that any of the other complementary policies and certainly the implementing regulations, they need to be harmonized, and I want to talk just a bit about that in a minute. One of the things that does, I think, cause us some concern is the fact that right now with federal climate policy certainly on very shaky footing, and when we see what's happened with the Western Climate Initiative and the Western Governors Association, where we frankly have more Canadian provinces involved in that than U.S. states. I believe we're down to just California and New Mexico. California does sit in a unique position. Now, having said that, we've led with Title 24 and energy policy before, and AB 32 is likely to be informative for the nation. But our goal would really to make sure is to support our statewide efforts, but also support a national carbon price, and if we have a carbon market, a broader one, because we do think that that'll smooth out some of the unique irregularities that having just a single state program would be. One of the things that we do think that SB 1368 that reduces intensity to 1,100 pounds per megawatt hour, that's a valuable tool. It's effectively eliminated coal from California going forward. But we also think a similar carbon intensity at the national level would be beneficiary. It's not an issue for SMUD because we don't have any resources today above that intensity level as it is. We also have AB 2021, which requires that 10% of electricity be met through efficiency over 10 years, where actually at SMUD we pledge to do 15% because on a loading order basis, we frankly think energy efficiency is the best investment to make first. And this is the issue where we start to run into harmonizing what might be best for one utility system to the other. We're totally supportive of the complementary measures, but we do want to make sure that in some cases they don't have unintended consequences. We have circumstances where we have utility systems that are 100% non-emitting hydro, and does it make sense for them to lay off part of that hydro in order to purchase renewables? And so those are the kinds of things when we get down to the ground level and individual utilities that do create conundrums. We also have the issue of renewable energy credits. We had a discussion this morning about there are very, very low cost renewable energy credits. But again, our utility, we've preferred to have delivered renewable energy into our system for the benefit of our customers versus stripping off the RECs of Iowa wind and then just paying for a low-cost REC. And again, we would argue that those RECs at some point will become more costly if we do end up with a national program. And then finally, RPS and RES, we've supported ARB on the RES, even to 33%, but we have been concerned, in fact, we were not supportive of SB 722, which was a bill that failed at the end of the session, that would have taken us to 33%, but require a large percentage of that to be developed in state. We don't believe, and I think Meredith's slide shows, we actually do import a lot of our energy from out of state, and in order to keep cost impacts down, we need to maintain the ability to bring in renewables over existing transmission paths, and also be able to get to those resources where they exist currently, and they exist at a development cost that may already be sunk. The other thing that we've tried to look at is other places where we might have contradictions between the end goals. One of the things, and we're very interested to find out, but one of the things we're hearing a lot is there's a lot of assumption about the elasticity of demand when it comes to energy use and how much people will really get off the system under certain circumstances. Heretofore, we've had an air conditioning load management program with 100,000 customers. We've had some time differentiated rates. We're now in the midst of putting in smart grid and smart meters to provide greater transparency and interoperability for customers. We're also doing a large behavioral study, and Meredith's actually on our advisory committee. And one of the things we're going to learn, because there's very few studies about how will people respond to prices when it's an opt-out versus an opt-in. Most of the studies done to date have been self-selected opt-in, and they've produced certain results, but when we try to get these things to scale to where we really see how people will respond to prices, we start to need to look at how will they respond if there isn't an opt-in component. So we are actually, as part of our behavioral study, doing a small opt-out component, which I heard we had a political science person here earlier, and they probably would have some opinions about how practical that'll be in application, but we want to learn that. It's very important. And then the last thing I would mention is we also have the smart grid that holds a lot of promise to produce transparency of price to consumers and also give them a better sense of their load shape and where their economic opportunities are. But at the same time, we have the federal government adding significant reliability regulations on us through the form of the National Electric Reliability Corporation, NERC, and FERC, the Federal Energy Regulatory Commission, and WEC, the Western Energy Coordinating Council. And all of these reliability requirements and cyber requirements on the smart grid, there's a train wreck that's coming where we're looking at progressive advancements in technology, but they're likely to be hampered by other arms of policymakers that are looking at regulation to shut down that very thing. So that's going to create a challenge. So for us, and I'll be happy to listen when we have the discussion and participate, our recommendations from a utility perspective, we would like to see an economy-wide program. We understand we're 24% in California and likely going to be 40% of the solution. We are stationary in some regards. There are better measures identified to clean up our emissions. We also do want to look across the entire continuum. So as we start to look at the electricity or the transportation sector cleaning up their emissions through electrification, we want to make sure we're not stepping on the balloon and moving the emissions to our sector without benefit for our sector of reducing it on our side. And then also, we need to balance at the end of the day reliability, affordability, and environmental stewardship. We have situations now where the policies, if they're not done properly, create huge swings and huge uncertainty for us. So the one thing for us that's very important, when we've been favorites of a carbon tax or something that's more predictable, is frankly, uncertainty is the biggest issue that stops investment and stops activity and leaves us kind of hanging back, waiting to see what the policymakers are going to come up with. So to the extent we can get a national climate program that we support, we can continue to participate with AB 32, and we can do it in a rational way that doesn't create huge winners and losers. I actually think that it's something that will not only be done by the electric sector, but also embraced.
Thanks very much, John. Next we have Dan Sumner. And Dan Sumner is Frank Buck Professor in Agricultural and Resource Economics at UC Davis, and he directs the Agricultural Issues Center. I think of Dan as Mr. California Agricultural Economics. He was born on a California fruit farm, I think between here and Berkeley, more or less. And he now works on topics like food safety and quality, farm subsidies, trade policy, and the environmental effects of agriculture. He has previously been on the President's Council of Economic Advisors, and he's been Assistant Secretary for Economics at the U.S. Department of Agriculture. So Dan is going to talk today on the impacts on agriculture, and I don't think there's anybody better qualified to do so.
Let me also begin by thanking Tom Rosenmolina, who's our man in black here today, for his assistance with this presentation. I'm going to talk about agriculture under AB 32, which hasn't had much discussion during the sessions here, and we'll talk about why that is in just a second. I want to get into some details about greenhouse gas emissions in agriculture and the cost of alternative cropping practices, which comes up in the context of offsets and some broader economic issues about agricultural impacts. Let's start. Most of the audience here doesn't specialize in agriculture or agriculture in California. The one perspective on that is where the land is used in agriculture. About a little over a third is cropland, but half of it is pasture. And it's important because agricultural land is a significant part, globally, is a significant part of greenhouse gases, and agricultural land use and the movement of land across crops and land from forest to crops, for example, is well known to be an important part of greenhouse gas emissions in agriculture and globally generally. What I won't deal with today is what are the effects of agriculture on climate change and what are the effects of climate change on agriculture. We're going to focus on climate change policy, which I think is consistent with all of the presentations here. There's been very little discussion about climate change per se, and that's appropriate for what we're focusing on, which is the regulations themselves. But I want to emphasize that because it limits the scope of the conversation. We've seen this slide a couple of times, saw it just a few minutes ago. What I want to highlight is along the side here, agriculture is about 1% of California GDP, slightly more, and about 6% of greenhouse gas emissions. So even though it's a relatively small share of all of the emissions, relative per unit of GDP, it can be a fairly big number. Within agriculture, and these are CARB numbers, within agriculture, about a third or so comes directly from fermentation within, that's methane, that's livestock. The manure management, nitrogen and methane is also livestock. So we're well over close to 60% associated with the livestock industry in the state. Then you get soil management, on around to methane from rice fields and a few smaller issues, including forest and range management, where, if you'll remember, was half the land used in agriculture in the state. Energy use on farms is about 13%. So that gives you a sense of what we're talking about. And residue burning, burning straw or burning prunings, is a very small share of greenhouse gas emissions in agriculture. So that gives you a sense of what the scope is for agriculture participating in emissions reductions. Under AB 32, agriculture is not scheduled to be capped. It's not a part of the cap system for a variety of reasons, probably because it was just too hard. CARB has assumed that agricultural emissions will fall under the scoping plan in agriculture. But as I understand it, they don't include that in their overall reductions. There's also seems to be an assumption that after 2020, we'll have substantially larger agricultural emission reductions. But again, those aren't built into the plan as a significant measure. Within agriculture, and this will be important as we think about where reductions are and where contributions to greenhouse gases are. The number one commodity in the state are dairy products at the farm level. Greenhouse and nursery is 2, and on down to the major horticultural crops, grapes, lettuce, almonds. This gets us to over half of California agriculture, but just over half. And the rest of the agriculture in the state really can sort of follow from the bottom 3 on this list. So along with grapes, we have lots of other tree and vine crops. Along with lettuce, there's lots of other vegetable crops. Along with almonds, there's lots of other tree crops. So California agriculture, really unique among the states in the U.S., is really quite diverse. And we ought to keep that in mind as we think about where contributions can come from. And one reason that CIRB and others focused especially on methane capture for digesters, particularly at dairies, and expected those to be implemented sometime in the 2017 to 2020 period, is because dairy is so important in the state. About 20% of national dairy production is in California, and California agriculture dairy is a very important contributor to California agriculture. I emphasize there's no mandatory caps, there's no mandatory policies as we understand it under the scoping plan, but there's some suggestion that there will be additional voluntary adoption of methane digesters with the specific policies that would encourage that, whether it's subsidies or something else that would encourage that, yet to be known. And that's the point here. One of the drivers with respect to methane digesters on dairies may happen through the offsets program, and I'm going to talk about that in a little more detail in a few minutes. There are a list of small indirect undertakings. There's some anaerobic digestion, that is agricultural waste that enters landfills. There's some research that ARB suggests that might reduce nitrogen fertilizers. Nitrogen is, as you noticed, a significant contributor throughout the system. And a few other small things scattered throughout agriculture that also apply to other parts of the economy. But none of these are very significant, and I'm not going to talk any more about any of them. Where I do want to spend a few minutes is talking about how agriculture is affected by things that happen out off the farm. And there, the most important thing are costs that will be faced, particularly in food processing, but also in the agricultural input industries. That is, you, even without capping feed mills or fertilizer plants or dairy processing plants, input prices will be affected, and the inputs that are used in the food processing sector will be influenced, particularly electricity and other energy sources. And we need to get a handle on that if we think about what the impacts of the regulation on agriculture. That is to say, it's not what AB 32 does directly on agriculture that affects the farming sector. It's what it does outside of agriculture that changes relative prices. On the farm, changing energy prices will affect particularly certain parts of agriculture. Rice, for example, rice costs are, operating costs on rice are about 17%. If you include fertilizer into energy costs, nitrogen fertilizer in particular is very heavily associated with natural gas. Wine grapes, about 9% when you include fertilizer. So those are costs on farms that are directly attributable to energy costs. If you affect energy costs, you affect the cost of production for these farms in California. When we get to the food processing industry, we want to appreciate in particular what that often means. And what it often means is taking water out of crops or agricultural products. That's most direct when it comes to dairy processing. A big chunk of the dairy in the dairy production in California is marketed as dry milk powder and butter and cheese. A lot of that is basically taking water out of milk. How do you do that? You do that with energy. And so dairy processing is particularly energy intensive food processing. That also happens in wine production. It happens in turning fresh tomatoes into tomato paste on down the line. So as we work through the effects directly on agriculture, that is the farming part of agriculture, we have to think very hard about the food processing industry. Obviously, if you raise the costs in the food processing industry, that industry will offer lower prices for those raw materials. That's a standard result. Where that has two effects, and we heard about these kinds of effects this morning. One is to reduce production. Production may move out of the state where it's flexible. That doesn't happen for something like the wine grape industry, which is largely going to stay in the state because of land resources. In agriculture, then, there are two effects of that. One is lower land prices, and the other is higher consumer prices. And that depends on the demand facing California agriculture. Just as a little aside, for example, the California almond industry is a very large chunk of the global almond industry. So that as almond drying, for example, and shelling costs go up, that would mostly be reflected in higher consumer prices for almonds. You don't have the almond industry leaving because of California unique resources. And because they have a very high share of the world market, more inelastic demand, we see a higher price effect there. When it comes to something like particularly wine grapes and wine produced in the Central Valley that is competing in a very elastic global market, we'll see that more in terms of land prices here in California because there's not a capacity to increase prices for those products. So those are the kind of shifts we see within production agriculture because of things that are happening off the farm. And that may have been what I say on this slide. Now let me turn to offsets and allowances. And we've heard a lot about allowances this morning, and that has to do with cap and trade. What's important for agriculture directly, for farming directly, is the offset side of the problem. And that is, and we heard something about offsets this morning, there'll be some flexibility for industries that are capped to buy offsets from uncapped industries, some of those within the state, some out of the state. Production agriculture is one of the places that could potentially sell offsets to firms that are capped. So you can think of rice farms selling offsets to SMUD, I guess. And that's a very important potential for production agriculture. There are two things to ask about that: how much revenue could be generated, and secondly, how much slippage there is. Will we actually get greenhouse gas reductions during that process? One thing that let me get to this in a second. I think I've just said what CARB looks at for offsets are partly methane digesters, but also cover crops and practices on farms. There's a whole range of practices that are potential. None of these are really set yet. Nothing's been certified yet for offsets for agriculture or for other things. Biofuels is another potential for offsets. For offsets to be considered, we get this word additional again. That is, they have to, it has to be something that wouldn't have otherwise happened. That's this notion of leakage. They have to be permanent, so you can't get offsets for doing something that then you reverse the next year and then sell it again on the third year. People are trying to avoid that. That becomes very important for agriculture because it has to, because tillage practices are reversible. Leaving biomass in the field is easily reversible. And so to have some sort of effect on greenhouse gas reductions, you need some permanence there. And the other three listed there are quantifiable, verifiable, enforceable. That is actually being able to certify, in a sense, that you're really getting some offsets. Let's go into a little bit of detail there. The kind of offsets we're talking about in agriculture are abatement, that is keeping emissions from ever happening, really. And livestock, capturing livestock waste, for example, and not letting the greenhouse gases ever be emitted are a good example of that. Conservation tillage as a sequestration has been proposed, but it's not widely practiced in California agriculture now, and it would take substantial encouragement for that to happen, probably substantial benefits. If you've only got 2% of the annual cropland, not including the permanent crops, currently using these techniques is a suggestion that they're not generally practical for much of California agriculture. Efficiency is a third, and there are a whole list of potential efficiencies. One I'll mention is nitrogen use, and there's some suggestions that with some encouragement, particularly focusing fertilizer where the yield increases are most likely, may allow farmers to reduce fertilizer use and keep yields high. That's one of the offsets that could be encouraged. There are a series of papers just beginning to come out that look at these alternative cropping practices, so away from livestock now, where the methane digesters are talked about, but thinking about alternative cropping practices. There the notion is to reduce nitrogen emissions, and doing that in ways that are permanent. The problem with conservation tillage is a lack of permanence to be able to qualify as an offset. And some suggestion is you can decrease fertilizer use thereby reducing nitrogen emissions, and end up reducing yields by somewhat less than 8%. So emissions per acre fall, but emissions per unit of crop output don't fall quite so much. One of the features of these kind of models that is important, and the second one I'm going to talk about is quite similar, is that there's lots of variation across agriculture within a crop. And that has to do with especially soil types. And California is very heterogeneous. So as it turns out, as you go across crops, the same practice or the same sets of practices have very different emission impacts. And that is one of the reasons that offsets from agriculture are so hard to verify, quantify, and so hard to put into an offset system in a way that's effective. The other is that models that do this, and in fact, people that are moving forward in the certification process, tend to focus on individual crops as opposed to looking at agricultural cropping systems and looking at emissions changes across crops. And I want to get to that because that becomes very important, and it can in fact even reverse the kind of impacts. Because obviously the simplest way to reduce greenhouse gas emissions from farming is to just stop farming. And if you only measure emissions per acre, then you've reduced emissions per acre a lot. What we have to remember is we're not farming just we're not trying to get emissions. That's not why people are farming. They're trying to grow rice or tomatoes or something else. So thinking of emissions on a per unit of crop basis, not on a per acre basis, is fairly crucial. And per unit of value is even more crucial. And this has to do with thinking about abatement curves of the sort we've seen Chris drawing pictures of and others have talked about throughout the morning and early afternoon. Let me talk about alternative cropping practices for rice for just a second. Rice is unique because of the methane release from decomposition of biomass under the water. That happens in two ways in rice production in California. One is during the summer, fields are flooded, there's decomposition, that releases methane. So one of the ideas is to drain the field sometime in the middle of the summer, dry it out, get less methane, and if you can do that in a cost-effective way, you can perhaps qualify for offsets or credits and gain some revenue. And if you can do that in a way that doesn't raise costs or reduce yields, that can be effective. The alternative is to do less winter flooding. California agriculture used to burn most of the rice straw. That's probably better when it comes to greenhouse gases. It's worse in terms of particulate matters. That's mostly outlawed now, both because of a statewide reduction and because burn permits are so difficult for rice farmers to get on any given day. So that most of what we do now is flood the fields in the wintertime, not just with rain, but with applied water, keep those fields flooded. The straw then decomposes, and then it's easy to plow in later in the year. That decomposition, of course, releases methane, just like it would in the summer, and that's a problem. So two ways to reduce the methane is to do less of the flooding, both in the summer and the winter. There are also some other practices, direct seeding and some other things that change the way fertilizer is used. We've been involved in a big study that looked at 6,000 individual fields across the Sacramento Valley with a modeling effort to ask if you change practices, how does that change methane and other emissions as well, nitrogen, especially emissions from rice production. And there are a couple of lessons from that. One is the biggest cost for those practices tend to be foregone yields. The practices don't vary much when it comes to actual operating costs. They do vary in terms of the yield potential from the crops. The second is that most of these, when you measure it on a per unit of rice basis, most of the methods that people have talked about or practices within rice have relatively modest greenhouse gas reductions on average. Withdrawal of the mid-season flood water during the year is not cost effective in most cases. The winter flooding, the opportunities to reduce winter flooding are more likely to be cost effective. But probably the most salient result is that there's huge amounts of heterogeneity. And that heterogeneity suggests that it's a relatively small share of the total acreage of rice that would account for much of the methane emissions. And that has to do with soil types, and it might suggest that that land could be encouraged to be removed from rice altogether or planted to something else. Now, I raise that particularly because, as best I can tell, nothing within the current suggestions for offsets have that kind of policy in place. That is to say, the offsets are typically defined crop by crop, and so the rice industry, for example, or the dairy industry or the wheat industry would be trying to develop some protocols so that they could have certifiable offsets, but you don't have anybody doing that for movements across crops. So if you think about a scenario, let's say I'm growing tomatoes. The tomato industry has developed a set of protocols such that we can get offsets. I adopt one of these practices that's profitable for my farm. I get some money from CARB or somebody, maybe from SMUD. That's a profitable thing to do. That will encourage additional tomato acreage. But tomatoes may be, in fact, more greenhouse gas intensive than wheat. So I shift from wheat to tomatoes, get offsets, greenhouse gases go up. That's a very likely scenario under the way we're doing it if we do it crop by crop within California agriculture. I stress this is not a scam. This isn't, David Victor referred to 2/3 of the either abatements as being sham. This isn't anybody being crooked. It's just the nature of the way we set up the regulations, and we seem to be going in that direction. We may be able to reverse that. The same has to do with the global impacts, and here let me just take 10 seconds to say it's been a big debate within the biofuel notion of whether we get emissions reductions using biofuels, having to do with the global economic impacts of changing relative prices of crops. The same thing can happen within California agriculture. If we, say, reduce rice production to take advantage of some offsets here in California, and that causes additional rice production in China, global emissions can well go up. We wouldn't capture it within our system. Since the externality is global, the regulations are local, we may well make the problem worse in a global way. And that's something we have to be very careful about because of heterogeneity. Brian, I know my time's up, so I think I'll stop there by putting this slide up, which just reminds you that we haven't talked about the effect of climate change on agriculture. We haven't talked about agriculture's contribution to climate change. We've only focused on the policy side. What does AB 32, what would AB 32 do, or for that matter, the proposition do within agriculture? And the answer is, as usual, things can go in a lot of ways, but I think within agriculture particularly, when we get down into the weeds, we ought to be very skeptical that the offset kind of programs really will reduce greenhouse gas emissions for agriculture unless we get the details right, and that's hard.
Thanks very much, Dan. It's my pleasure now to introduce to you David Zilberman, who needs no introduction. He's a member of our department at Berkeley, and he's a member of the executive board of the Energy Biosciences Institute at Berkeley. He conducted pioneering work on payment for environmental services and on adoption of technology in agriculture. His recent research focuses on how climate change policy impacts agriculture and food markets, the economics of biofuels, and the efficiency of low-carbon fuel standards. He's going to be talking today on the impacts on energy prices and the economy.
I would like to speak about some lessons from economic research that we are doing now or was done in the past that have implication about how you think about Proposition 23 and AB 32. First, I'll speak about the relationship between energy prices, land use, and financial well-being. Basically, how energy prices affect land values, housing values, and how it affects the financial situation. And then I'll speak about adoption of green technologies because we have done some research on this topic. My work on energy prices and the financial crisis is work that I've done with Jinji Wu and Steve Sexton, but I'm not sure that they agree with everything I say. So, the first thing I'd like to look and speak about the relationship between land use and energy prices, because as you see later on that it has two implications about the proposition. I start, all of us, or people that know economics, know that one of the most powerful and durable theories economic is land economics that started by a fellow named Van Tunen many years ago. And basically develop principles to understand land use. And the key point is that land is a heterogeneous resources. The value vary by location. Distance from a city or from urban center is a key variable. So if you look at different locations that produce the same product, the value depend on transportation costs. So generally speaking, one of the implications is that you really look at this. If you have a city, near the city, you will have crops that are more intensive, like intensive wild crops, livestock and veggies, and then you will have field crop. And generally it works. Later on, you can have that in the cities, you have industrial, residential, suburbs, animal production, and field crops. And later on, you can make dissertation, you can introduce environmental considerations there, but this set of issues are very, very important. Now, generally speaking, the inverse way to look at it is that generally you have urban weight, that is in red, and so the city is, as long as the urban is the red above everything else, the dairy is where the green is top, and above it is when field crop are most profitable. So this is a very simple theory that can really start, that is the start of our analysis. Now, if we look at housing, there is urban economics that basically try to look at the value of housing within the urban zone. And generally today, one of the main applications of applied economics is that every real estate add-on has a formula that is called a hedonic pricing formula that's basically based on this principle. So if you look at the value of a house, it depends from size, physical amenity, location, environmental amenity, also expectation about interest rate. And generally speaking, if we really look at location and income and prices, is that if everything is equal, the only thing is distance, richer people will live closer to the action to poorer people because the poorer people will have more time driving. And housing prices will be close to the cities and farther away from the city. Now, so if you look at suppose the energy prices are low, so the grid of housing prices is this blue line where you have the value as function of distance. Now suppose that the energy prices goes up, the prices go down, but which prices are affected most? The prices of the poor people. Moreover, what may happen that if energy prices will go up, some of the prices closer to the city will actually go up because people would like to save transportation costs and be close to the city. So what the basic point is that when you will have higher energy prices, you really have reallocation of the value of houses. Some people farther will lose more, some people closer to the city will gain, and you remember that the people that are farther from the city are relatively poor people. Now, there are other considerations. Obviously, if you look at California, the student that did his dissertation, aesthetic value matter. So if you look at three regions, Marine, Napa, and Solano, Marine, basically good views, close to the city, most expensive. Napa, good views, far from the city. Clipper, and Solano, far from the city and not that good views, very poor. So the theory can be verified. Also, we have a lot of people, poor people that live in the city. But generally speaking, this type of idea that the farther you are from the city, value of houses go down, is quite verified by a figure here. So the area that is blue near the coast is much more valuable than areas in the Central Valley. So generally speaking, if you really look, distance matter, and generally income is associated with high transportation costs. So what happens if energy prices will go up? They will have a stronger negative effect on the price of houses farther from the cities. They will also have higher impact on the cost of driving. So these are two effects. So now let's look at the economics of mortgage. You will take a mortgage if, when you buy a new house, the benefit from new residents and price appreciation is greater than the transportation cost plus interest payment. On the other hand, you will give up your mortgage if the benefit from new residents plus price appreciation is smaller than the extra transportation cost and interest payment. So so this is one point. Now, then we introduce cash flow consideration. You will take cash flow if the earning minus debt, expenditure, travel cost, and mortgage is positive, and you may give up your mortgage when, or the value house will be underwater. You may give up the mortgage if the value of the house is underwater and transportation costs are increasing. So what happened when energy prices are increasing? When energy prices are increasing, two things will happen. First, the value of houses farther from the city will go down. Secondly, the cash flow of a lot of poor people will become negative. Now, if you are a poor person, that you bought a house under the assumption that energy prices will be low, and suddenly you got a low down payment, that all the problem of the financial crisis and mismanagement, all of us know the story, and suddenly you have to pay $200 more a month on mortgage for a house that is underwater. Why would you keep the house? So I think this is a basic point that happened in California and other areas. In the early 2000s, many people received mortgages with low down payment. They thought that they were great. A lot of people didn't take into account balloon payment, but not everyone had balloon payment. I myself was getting offered to get houses under good condition with zero interest rate. My kids got offers like this. But when energy prices went up, the cash flow became worse. The home value went down. So the net effect is increased default rate. So if you look at California in 2008, even with this lighting, you can see where are the bed. You see the dark area? These are places that are that are in Merced County and in the Central Valley or in San Bernardino. These are commuting communities. Now, there are a lot of things that cause it. I really think a lot has to do with environmental regulation. How many of you know that we have a limit on 7.5 million people in the Bay Area? We have a limit because it's ABEG, Association of Bay Area Government. So if we have this number of people, so if you want to have more people, they will go to Merced. They can actually get a nice house in Merced. And because we wanted to have a home-owning society, everyone got good mortgage. It was a combination of Democrat and Republican that have this illusion. So people lived in Merced, lived in these houses. Suddenly the price of energy went up, and this guy really got screwed. Now, in this area, in San Bernardino, you know how many people, you know how many investors start building houses in that are about 150 miles in Los Angeles in the Coachella Valley? What do they do? They don't pick dates in the Coachella Valley. They work in the Long Beach port. So people that drive $150 miles a day to go to work in Long Beach. The price of energy goes up. These guys are in trouble. Their income is $3,000 a month. $300 or $400 a month is a big problem. The value of the houses go down, and a lot of these people really got screwed. So the basic point is that high energy prices is a big problem. Now, if you look at this number are frightening. Look at what percentage of the houses are underwater. These are the ranking in the country. Number 2 city in the country in terms of negative equity is Merced, 67%. Stockton, 65%. Modesto, 65%. Vallejo, 64%. Yuba City, 63%. Riverside. Basically, you look at this feeds the theory. The areas where you have the largest number of bankruptcies and the low housing value are these areas. So what are the lessons? So one value is don't raise energy prices. So basically, Proposition 23 is great. We want to keep energy prices down. But there is a more profound lesson. We basically screwed up by ignoring what's going on with energy. I'm a new American, but I feel a little bit embarrassed that Fiat's supposed to save GM, or Chrysler, and Renault. So basically, we didn't pay attention to what's happening with energy prices. We don't pay attention that relative prices of certain things go up and we don't change technology. So to some extent, there was a big mistake, and a lot of it is environmental regulation in the fact that we basically, for short-term gain and aesthetic value, we basically decide that every house will be small with big lawn, that because of endangered species. And I believe me, I do a lot of the analysis. Instead of having 300 units on a piece of land, we have only 80 units, and there will be high-income unit, and then people go to Merced. So to some extent, living with reality and taking into account that climate change may not happen 100%, but it's a reality. The fact that we lost the automobile industry, and okay, we gained. We have Facebook and Twitter. Great. But we really lost the automobile industry, and if we don't realize that we have this reality, we are in a little bit of a trouble. So I can understand. Someone said, good, we really were in trouble. Let's keep energy prices low. I can understand that someone else said, we really have to think about the system, how it works. So now I'll go to another topic, what we learn about agriculture, from agriculture about innovation. I think the one thing that I feel about agriculture is that we were studying what's called input use efficiency when it wasn't cool. Now everyone studies input use efficiency. We were doing it for 30 years. And one of the policies doing is we look at irrigation. Now, what happened in irrigation, people can adopt traditional irrigation or something like drip irrigation. And one thing that is clear, the early adopters are people that really have to pay higher prices. So people in San Diego with deep well-adopted drips. People in the west side of the valley adopted sprinkler. People that have subsidized water don't adopt anything. People that have more money, fruit and veggie, adopt more. But generally, the adoption process was gradual. I don't expect that people will adopt new refrigerator and stuff like this, not because they are irrational or it's a market failure. Basically, there are psychic costs. Why would I give a damn about a refrigerator? And if it takes, so you really need to have some sort of regulation, or you need to raise the prices that people will pay attention. Generally speaking, in California, irrigation technologies or all the intensification, and we have incredible intensification that happened in California agriculture, occur during period of crisis. Basically, there were 3 periods where adoption occurred very fast. During drought periods and during very high income period. And the reason is, especially drought period, that people brought this stuff, suddenly paid attention to some of these things and introduced it. So altogether, once we had the prices were right, and even though the price of water still are distorted, people adopted some of these technologies and it really made a difference. So I don't think that discounting the potential of input use efficiency is reasonable, but it takes a long time. It won't happen tomorrow. Something similar is about the issues of what's called green industry. Several years ago, about 10 years ago or something, the state introduced pesticide regulation application registration requirement. You apply pesticide, you have to register it. Oh man, the farmers were complaining and they asked us to write papers and stuff like this. It's really expensive. And for a year or two it was a problem. But then suddenly people realized that you can use software. And then people start using cell phones and using all this wireless technology to to register their application. And the thing that killed me, that during the Bush administration, California people were really recommending that this type of procedure will be applied nationwide. Furthermore, the same technology that you use to register pesticide use, now people use for traceability and even to register the farm workers. That's the main technology that people use, for example, to deal with documenting illegal or legal migrants. So the basic point is that all these things that called green technology that is induced can occur. It doesn't occur overnight. It took about 10 or 15 years till it occurs. Sometimes it doesn't occur at all. But to some extent, you cannot totally discount it, but again, you don't expect this notion of shovel-ready. When I heard that people say, we will spend money on shovel-ready green technologies, I knew we have a problem. You need to develop a system that allows this technology to be introduced gradually. If you, for example, increase the price of energy, at least in the first several years, things will happen very slowly, but then hopefully creativity would lead to something. So altogether, if I try to look at it in climate change in perspective, even if you have 50% chance that something will happen, we have to pay attention to it. And the other thing about climate change, that a lot of the reason that people care about it is not climate change. Fuel cost and fuel security is a really big issue. The issues of balancing growth and the environment is also important because if you reduce climate change gases, you deal with air pollution. So there are good reasons to deal with it. Now, so we need to look at some actions. Now, the actions that we need, I think, require a lot of the actions that we need are actions that basically allow capacity to adapt. So, for example, one of the things that we have today in California agriculture and in the state is the regulatory system that is very, very flexible. Basically, today, if tomorrow we really have climate change and we have to move that as the wine industry a little bit to the north or to reallocate anything, it will be impossible because the zoning, endangered species and everyone. We need to have a legal system that is much more flexible. We need to rethink our building regulation that will balance flexibility with environmental regulation. We need to price carbon, and ideally for me, a fuel tax will be great. A cap and trade will be good. I really think that some mechanism, and I think a tax reform that will combine moving to energy taxing and reallocating the resources, for example, to reduce fuel taxes is really important. The point is that if as academicians we say that everything is impossible and we didn't say that the current solutions stink, no change will happen. All the things in direct land use, all the policies that people bring today are second best policies, and the thing about second best is they are second best. So we know what is the first best, and the first best is to introduce market mechanism, to use the proceeds to eliminate inefficiencies elsewhere and to move forward. So altogether, my conclusion is that it's too similar to Rob Stevens. AB 32 may increase a little bit of prices, but on the other hand, it really may shift resources, so the economy will move to a direction that will allow us to realign itself rather than we will be in a situation that we are lagging. So basically, you have a trade-off between the high prices that may occur and the other thing, the higher prices that may occur in the future if we basically ignore what's going on today. But more importantly, we really have to reassess our environmental regulations as well as our land use regulation, because the path that we have taken in the last several years and the inability to basically even to express what we think is quite problematic. Taxes maybe is a dirty word, but inaction is even dirtier.
I think it's pretty clear that on this panel we have what one national politician a few years ago referred to as the reality-based sector being represented here. I encourage you to try to draw these people out of their shells so that they can tell you what they really think in some questions. Yeah, over here.
Thank you all for your comments. Jamie Fine with Environmental Defense Fund. Professor Zilberman, you just said you agreed with Dr. Stavens, and then what you said wasn't really what I heard Dr. Stavens say. So I'm hoping maybe you could clarify your point. And I'll just say what I thought I heard Dr. Stavens say was implementing AB 32 isn't a great idea because of the free rider problem. And he also applied that concern to national policy in the absence of international policy. Maybe he said something else that you were keying off of, but I'd love to hear you just either restate or clarify your point. Thank you.
The basic point that I think that he said is the bottom line. If I was in the State Assembly, I would fight that AB 32 would be done differently. But given that it is now, I think it would stay because it really established some commitment to address a big problem and basically say that we really realize that we have energy price and climate change problem that we have to. It's not an optimal policy, but abolishing it and basically, I don't think that my view will will be very problematic and painful in the long run. And I think that was his bottom line.
Stacy Sullivan from Sustainable Conservation. I'm particularly interested in the comments on methane digesters, something our organization has been involved with for some time. And you're hearing all of these projections about, you know, all these potential greenhouse gas emissions that could be realized from them. We sort of run into certain problems. In the case we've run into in trying to get methane digesters going in the Central Valley, they run into air quality regulations. While they may be great ways to reduce greenhouse gases, the current technology doesn't meet the extremely strenuous NOx regulations. When you were talking about the rice straw situation and the fact that we used flooding was seen as this great technological sort of like environmental breakthrough to get away from burning that now leads to methane generation, and we're trying to think about how to pull back. And so this gets, I guess, sort of a general question about how do we, one, make sure that all of the necessary factors are entering into our considerations when we try to develop these policies. I so heartily concur with the idea that we need to come up with a more flexible regulatory system and a less siloed regulatory system. But how do we, what kind of criteria would you think we would need to apply in order to both make sure that everything is on the table, but also that we create the right kind of balancing mechanisms when we have these conflicting issues?
Okay, before I turn it to Dan, because he's probably the right one to answer, I would just say that when he spoke about methane digesters, we actually had 11 dairies within SMUD's area, and so we did look at that, and we developed 2 of them, and we ran exactly into what you were suggesting. And so to me, we ended up with NOx issues that ultimately, even though there was significant emissions benefits, the regulations related to other constituent pollutants proved to basically make the projects not economical. And we had that in our air district. I know there was issues also in the San Joaquin Air District, same thing. So part of the issue for me in harmonizing regulation and policy is to making sure that at some point there's a recognition of trade-offs and a priority to what is the greatest value on an integrated comprehensive standpoint versus looking at all these things individually, which ultimately might be at cross purposes from the overall goal. And if the overall goal is reducing carbon emissions, we're going to have to reconcile the trade-offs of other pollutants and other issues along the way.
The interesting thing that's different about the methane case in digesters in rice is that in the case of rice, we reduced what was perceived as a local environmental problem, the particulate matter, and found ourselves with a global problem, the greenhouse gases. With the methane and the NOx, with the digester and NOx issue, we would be trading what's been identified as a local problem and for what I think everyone acknowledges is probably essentially no gain in greenhouse gas globally, except to the extent that we are a political example for the rest of the world. So the lesson there, and we were talking about this earlier, the benefits of a cap and trade or a carbon tax that takes account of picking the low-hanging fruit broadly across climate change or greenhouse gas notions. We probably do want to try to broaden that, even within environmental policy, so that we ask ourselves, getting the biggest bang for the buck for environmental benefits, broadly speaking. Now, what that forces us to do is what we actually already do politically, but we could do it in a more systematic way, and that is account for the relative payoff of reducing local NOx problems versus global greenhouse gas problems, and actually put some prices on those things. We do that implicitly through a political system in a pretty chaotic way. The way to do it systematically is to put, in a sense, all these pollutants in a pot and actually put some prices on them. And that's easy for me to say because I'm an academic. The next panel, but also I think the next panel, also largely academics, are people that are thinking about implementing these things in a political economy way, and so part of this is exactly their topic. If they don't answer it, ask them again.
Renata Brillinger, California Climate and Agriculture Network, and my question is for Dr. Sumner. You were disciplined in your presentation to stay away from commenting on the impacts of climate change on agriculture, but I would still like to know if you, given your comment that you don't think offsets are going to be necessarily that lucrative, given California's diverse agricultural industry, what would you think about the possibility of looking at the allowance side of the cap and trade program as a possible way to support adaptation measures that agriculture is going to need to undertake and enhance the sequestration potential?
Well, I'll defer to some extent to people who are here from CARB. Maybe they can answer this, but my understanding of the allowance side of things is that that's limited to the capped industries. Is that right? So the proposal then would be to cap agriculture, bring it under cap and trade, impose some reductions on on greenhouse gas emissions from agriculture, and then other parts of agriculture then would be eligible for the allowance process. I don't know anybody from within agriculture that's standing up volunteering to be capped and then reduced. Maybe that's your proposal. I couldn't quite tell. But I think that's just maybe a technical sense of the word allowance.
Yeah, what I was referring to
was
was the potential for revenue to be generated from cap and trade, from the sale of allowances.
Yeah, or the sale of offsets. That's right.
Exactly.
And I guess I didn't speak to how big that potential was, partly because we're not very far down that road, frankly. What I did want to raise a substantial amount of skepticism about is well, let me put it this way. To the extent that selling offsets is profitable for agriculture, it'll probably be because those offsets, in fact, don't do much for greenhouse gas reductions. Because, and that may sound paradoxical, the more profit the farmer makes from it, the more he's getting paid for stuff he would have already done anyway that doesn't change his behavior very much. And that's just the nature of the arithmetic, really. Now, that could be good for the farmers, but it probably doesn't achieve, I mean, that's the slippage that everybody talks about in this process. The other point I was making, again, not revenue to farmers, but was that it's very hard to define these offset systems such that you actually take into account the trade-offs across crops and across enterprises, even within agriculture. And that is so difficult that I am really quite skeptical that we're going to get very much in terms of greenhouse gas improvements. farmers may come out way ahead, and we know that they already have in certain areas, some of the biofuels areas that are now, biofuels has been a bit of a mission creep. We've had lots of reasons to subsidize biofuels. One of the current ones over the last roughly 80 years that we've been periodically subsidizing biofuels. But one of the reasons currently has to do with climate change. And there's a case where there's no question the corn industry made a good bit of money there. Whether it's had any positive impact on climate change is much more debatable.
Can I say something?
Yeah.
During the Clinton year, I was actually working on a program that tried to look at soil carbon sequestration. And the thing that was, and other things, the thing that was amazing, that in almost all of this program, other states could gain from a lot of legitimized carbon sequestration activities and other activities, but not California. And the reason is, you may do something in the field crops, but in other areas, the issues of slippage are quite substantial, and the order of magnitude of saving is very limited. Now, one can introduce a system of payment for environmental services when you have benchmarks and you basically document a lot of things, but everything has to be built on a system where you basically make money when you save, but pay a penalty when you emit more carbon. And I think that one of the biggest problems that you have in agriculture is asymmetry. It's very difficult for me to say a farmer that basically sequesters, that go non-tillage for 10 years and makes money after 10 years when he plows the field, basically is paying back. So this element of the difficulty to implement irreversibility will make it very, very difficult. So you need to have a lot of discipline, a lot of political will, and I understand why people basically didn't really like to take this type of activity.
Hi, Jamie Fine again with Environmental Defense Fund. I have a question for Dr. Fowlie. I'm not sure if I missed this because I was busy digesting the delicious lunch, but in your analysis, I did see clearly your conclusion about the contribution that the electric utility sector was going to be making to achieving our greenhouse reductions goals. In the conversation on the topic of Proposition 23, there's been a lot of misinformation put out into the public about the actual translation of AB 32 into energy costs. False statements like energy prices are going to go up 60%. I'm wondering if you got any insight into the impacts to consumers and their electricity prices under different AB 32 cap and trade design scenarios, and if you'd be willing to comment. Thanks.
So I guess for so for one, I was, as I stressed, I was a consumer of, not producer of, so it is hard to interpret all the assumptions that go, and I guess I'm going to punt here. I mean, one point is it's really going to depend on the details, how the allocations are distributed, to what extent LSEs or load-serving entities are instructed to use those allocation values to mitigate impacts on consumers. So I guess I'm going to have to leave it there in the sense that it's really going to depend on how, especially for consumer price impacts, it's going to depend on how the allocation rules are laid out and those kinds of details. I would defer to folks who worked on the analyses that I was sort of digesting to help us understand some of the assumptions behind those models that sort of drive the price effects in those models.
Any other questions? Okay, well, I want to congratulate the panel. It looks like we're back on time, but that didn't mean we didn't get a lot of information from this panel. I think that is a good round of applause.